This is Chapter 1, Chemistry and Measurement. Chemistry is basically the study of matter and how it changes. Matter is anything that takes up space and volume. Probably the first time you learned about matter was second grade. The definition hasn't changed. When making observations, there are two basic types of observations, qualitative and quantitative. When you think of the word qualitative, what word does that sound like? Hopefully you said quality, because qualitative observations comment on like the quality of something. So, this iPad is heavy, this iPad is square, this iPad is black. This picture you see in the right-hand corner is green. Those are all qualities or traits. Quantitative sounds like the word quantity. And so that is an observation that actually has a number associated with it. This iPad is about, a foot long. It weighs about, 4 pounds. Notice all of those observations have numbers associated with them. Here are some other qualitative and quantitative. Let's see if you could figure out which one's quantitative and which one's qualitative. Spend about 20 seconds right now doing that. Hopefully you noticed the ones with measurements. The tree is 10 feet tall. The water is 25 degrees Celsius are quantitative because they have a quantity. The rest are qualitative. They do not have an actual measurement. They more describe something. The scientific method is something you've probably also learned in the past. It involves a reasoning, logical way to solve a problem. So take a second and glance at the slide. We're going to be doing a lab that has to do with the scientific method. And please make sure that when we do the lab that you remember about good observations. Here's the rest about the scientific method. Again, spend a couple seconds glancing at this. You might want to refresh your memory about what a variable is by reading the slide and looking at independent variable and dependent variable. Remember, at any point, you can rewind this video or press pause to spend more time reading the slide. So now let's take a look at this example. Three glasses of water, each with the same volume and temperature. Glass A is placed under a lamp for 1 hour. Glass B is placed under the same light for 2 hours. And glass C for 3 hours. After the assigned times, you measure the volume of the water in each glass. So from your results, you can hypothesize that the water volume decreased as time under the lamps increases. All right, so that is your scenario. Now here are the questions. What are the variables? What is the independent variable? What is the dependent variable? So again, take a second and see if you could figure out those questions. Also feel free to rewind the video and see what a variable is, what an independent and what a dependent variable is. Hopefully you said variables are the things I'm measuring. Okay, so in this instance, volume and temperature stayed the same, but the amount of time they stayed under the light and the volume increasing or decreasing was something that got changed. So basically your two variables then are amount of time and in turn, the volume changed, so volume. What is the independent variable? The independent variable is the variable you changed. So if you noticed in the lab, you changed how long they stayed under the lamp for. So time is something you changed. You had control over that. I always like to think of the independent variable starts with the letter I, and then I think, what is something that I changed in this lab? I changed how long they stay under the lamp. And then the dependent variable is what depends on that independent variable. Well, the volume left over in the glass depends on how long you kept it in the light. So the volume is the dependent variable. We are actually going to skip over this slide. Now let's take a look at measurements. You'll be also doing a lab that involves estimating and recording the levels of different liquids, or the mass of things, or an actual measurement with a meter stick or a ruler. And all of these objects and these pieces of equipment will be used throughout the year. So understanding how to read them to the correct place value is important so that you don't receive points off lab after lab. So measurements are made with equipment. Here are some common glassware you'll see throughout the year in the picture to the right. So, all these equipment, they have error in them. Some are better, some are worse. So, for example, hopefully you've identified that the graduated cylinder is one of the most accurate ways to measure liquids. This piece of equipment right here is called a volumetric flask. You're not going to see it too often. You'll see it in one lab. It is a very accurate piece of equipment. It's very expensive. So the graduated cylinder is probably what you're going to focus on the most. Notice the beaker. It is not a good piece of equipment to measure liquids. It does a good estimating, but not a good one if you want an accurate amount. So all measurements, let's focus here, they all basically have a certain amount of numbers, and you get one extra number that is a guess, and we call that the uncertain number. It is what we estimate, it is the estimated place. So let's take a look at this example. And yes, that pencil is blurry, so nothing is wrong with your iPad. Do not adjust. If I look here first at the ruler given to me right here, and I try to figure out what is the scale, and so if I notice here, these are called increments. If you notice I'm drawing down here, these are the increments. I see that I have a 7 here, and then I have an 8 here, which then means the scale goes up by 0.1 tenths is what it goes up by, right? Because this would be 7 right here. 7.1, 7.2, 7.3, 7.4, 7.5, 7.6, 7.7, 7.8, 7.9, 8. Okay, great. So it goes up by 0.1. With that being said, if I wanted to measure the length of this pencil all the way to the outer tip of the lead, I know for sure that this pencil is at least 8 something. And to be even more exact, it definitely is 8 point, well, let's see, this is 0.1, this is 0.2. So it's definitely 8.2 something. So I'm going to write 8.2. I think all of us could definitely say that, or hopefully all of us say that. Now, I'm going to see here, I'm going to kind of draw, oh, that's a horrible line. I'm going to redraw that. I notice that the edge of the pencil comes out to be right around here. Okay. So for sure, everyone should say 8.2. That is certain. Now, remember, you get to have one guess. So I'm underlining the place where I'm guessing in. That's the hundredths place for this particular ruler. At this point, your guess can be anything. For me, I noticed that the pencil lead falls between 8.2 and 8.3. So I'm going to call this 8.25. You could have guessed anything in the spot and probably been correct. You kind of get to have that for yourself. And let's just pretend that this is maybe inches. So let's give it a unit. All of our numbers in science will have a unit on them. So don't forget to label the unit. So we for sure can say that the first 2 digits in the measurement we just took are the same no matter who reads the scale. Therefore, since they're the same, they're called certain. That third digit was an estimated. Every scale is going to be different, so you might not have a third digit. It might be your second digit. That's why you have to make sure you read the scale and figure it out. So, as you could see below, any of those options in red would be accepted. If you just reported 8.2, you would have actually gotten this wrong because, like I said, every measurement should have the certain plus 1 estimated place. That's the rule.